Okay, welcome back. So in this session, we will discuss structure design patterns. And these patterns are primarily concerned with how objects and classes are composed to form larger structure. They help ensure that when one part of a system changes, the entire structure of the system does not need to do the same. Here are the key structural pattern with explanation and examples for developers and architect. Like what is the meaning and how developer perceive to the pattern and how architect should perceive the pattern. The list of pattern which we will follow: adapter, breeze, composite, decorator, facade, and flyweight and proxy pattern. Okay. And the next thing is, let's start not in too much detail, but little bit about the each pattern one by one, so that at least you should be aware of the basic fundamental understanding with patterns, so that when somebody wants to communicate in pattern form, you will able, as a developer or architect, you should understand that pattern brief overview. Okay, so that will help you. So let's start with adapter first. Let's start with the adapter pattern. Okay, so when we discuss about the purpose, its purpose is convert the interface of a class into another interface client expect, right? So adapter lets classes work together that could not otherwise because of incompatible interfaces. As an example, I would say, imagine a modern application need to use legacy code. An adapter can be created to allow new implementation to work with legacy code that expects different method calls. Now, this is the basic requirement, right? Let's try to understand the developer and architect perspective. So developer perspective, first, let's discuss. Use an adapter when there is a need to integrate with an existing class that has an incompatible interface. Let's try to understand the architect perspective then. An architect utilizes adapter to ensure that overall system architecture does not need to be changed when integrating new component or third-party libraries that do not match the existing system interface. So in that scenario, adapter is very, very useful. And this is the exact reason behind this adapter pattern. So I hope you briefly understood what is adapter pattern, and you also able to understand how the examples is making more clarity over statement of over the purpose of adapter. Then we also try to understand how developer perspective and architect perspective is for that pattern, like adapter pattern here, but in general how developer perspective and architect perspective is helping to understand pattern more accurately, right? That's why this is very important. So let's move to the another pattern, another structural category pattern, which is bridge pattern. So next is to follow as bridge pattern analysis. Okay, let's move on. To understand the bridge pattern now. The purpose of bridge pattern is separate an abstraction from its implementation so that the two can vary independently. Let's take one example here. If you have a website with different themes, a bridge pattern can separate the website content from the theme applied to this. This way, adding new themes or changing content does not affect each other. Developer perspective here is a developer might use the bridge pattern to write better organized code that separates an interface from its background implementation. Now, architect perspective here is, for an architect, the bridge pattern is a key tool in system design that helps in reducing monolithic application structure, make it easier to understand and manage. Okay. Next pattern to be discussed is composite pattern. The purpose of this pattern is compose object into a tree kind of structure to represent part-whole hierarchy. Composite lets client treat individual object and composition of object uniformly. As an example, I would say a graphic application can use composite to treat shapes like circle, rectangle, and group of shapes uniformly. Developer perspective on this pattern is developer can simplify their code by treating both simple and complex elements with the same interface, avoiding complex additional statements. Architect perspective here is architect use the composite pattern to build a hierarchy of objects which can be treated the same way, improving flexibility and scalability in the architecture. Okay. So the next pattern to be discussed is decorator pattern. Purpose of this pattern is attach additional responsibility to an object dynamically. Decorator provides a flexible alternative to subclassing for extending functionality. As an example, adding a scroll bar or borders to a window in a graphical user interface GUI can be achieved using Decorator. Let's try to understand the developer perspective. A developer can apply the Decorator pattern to extend an object's behavior without making new subclasses. Architect perspective here is an architect might use Decorator to ensure that system extension can be made without significant refactoring or re-architecting it. I hope it is clear. Okay. Next topic is facade pattern. So purpose of this pattern is provide a unified interface to set of interface faces in a subsystem. Facade defines a high-level interface that makes the subsystem easier to use. The facade pattern provides a single entry point to a complex system or a group of APIs, making them easier to use and understand. For an example, let's say a computer starting up might involve several complex operations, loading the OS, checking memory, etc. A facade can provide a start computer method which wraps all these operations into one, simplifying the interface for the user. Let's try to understand the developer perspective. Developer use the facade pattern to simplify interaction with complex libraries or APIs. Let's understand architect perspective here. Architects use the facade to create a simple interface to a complex subsystem, which is particularly useful when there are many dependencies between clients and the implementation, and the implementation class is of an abstraction. So facade is basically to create a simple set of interface over the complex subsystem. Okay, I hope it is clear. Let's move to next pattern, which is flyweight. All right, so let's try to understand the flyweight pattern purpose. Use sharing to support large number of similar objects efficiently. How it works. The flyweight pattern is used to minimize memory uses or computational expenses by sharing as much as possible with similar objects. It involves a flyweight factory that ensure proper sharing of the flyweight object. As an example, I would consider in text formatting, instead of each character in a document being represented by an object, character instances can be shared among the document where only their position differs. Let's try to understand the developer perspective also. It's crucial when implementing flyweight to consider immutability. Flyweight objects should not have their state change after creation. Let's try to understand the architect perspective. For systems with a huge number of similar objects that could lead to a high memory consumption, architects might employ the flyweight pattern to reduce the load. So until now we covered flyweight, we covered facade, we covered decorator, we covered composite, we covered bridge, and then adapter. So we are clear with this much information now, right? Let's move to another operation, which is proxy. Try to understand the proxy pattern now. So purpose of proxy pattern can be divided like provide a surrogate or placeholder for another object to control access to it. How it works. The proxy pattern involves creating a representative object that control access to another object, which may be remote, expensive to create, or in need of securing. As an example, a virtual proxy might be a placeholder for a large image. It delays the creation and loading of the image until it is needed to be rendered. Developer perspective is developer can use proxies for lazy loading, caching, controlling the object, or adding security check. Architect perspective is proxies can be instrumental in systems architecture for reaching the cost of operation or the memory footprint by postponing object creation, especially in distributed system for managing remote resources. Hi, good morning everyone. Today is 10th November. Okay, so this session is about to close my structural design pattern introduction video series. And this is just an introduction. So in this introduction, we have learned many things. Under this structure pattern, we covered adapter pattern, then bridge pattern, composite pattern, then decorator pattern, then facade pattern, and flyweight and proxy. So these are the 7 pattern under structural design pattern section we covered briefly. Just introduce these patterns for you. Of course, I will come with detailed information about these patterns with practical hands-on, the practical way an architect or developer should think, then also how to, if you know these things,
and you encounter with the problem scenario, problem use case scenario, user story which is producing these kind of problem for you, how you will tackle as an architect or as a developer to that problem. Because see, implementation is one aspect of doing the task, but thinking in a design way, how to design for a well-maintained, well-structured solution to some programming, coding, real projects problem is another way of thinking. And here is the difference comes to one, normal engineer and one who is, skillful engineer of that domain, right? So that kind of difference comes with these kind of attributes. So yeah, so this video is just about the wrapping up the things in the world of software development. I'm wrapping this section by saying that in the world of software development, structural design patterns are like the beams and columns in architecture. They don't just hold up the structure, they also dictate how different parts of the system interact with each other, while the patterns work together to produce the excellent output as a software product or services for your end customer, end user. This is the beauty of this design pattern. I hope you like it, this section to introduction of your structural design pattern section briefly in this video. And I hope that I will see you in the next video in this series very soon. तब तक के लिए अपना ख्याल रखें. Thank you. Thanks a lot. Bye. Take care.
Thank you. Thank you for completing this video. And I hope that you definitely have learned something which will help you in your system design interview. Hope to see you in next video with new concept and skills needed for the system design interview. By then, keep learning, keep improving, and keep sharing your knowledge.